Okay, hello again. So, how to solve a question if we have a square root in the denominator or square root in the function? So, let's say if we want to solve the question 20, so we have a square root in the denominator. So, how to find, we have to start with finding the domain. Okay, so question 20. So, finding the domain. First of all, I have even root and I have rational function as well. So I have a denominator and I have even root. Now for the root, the expression, it has to be, the expression inside the root has to be greater than or equal 0. But, but because this square root in the denominator, we have also to exclude the 0 because we cannot take a denominator equal to 0. So the expression has to be greater than 0, which means over here x squared, it has to be greater than minus 1. Then we have to take a square root. Okay, so square root of minus 1, we cannot take a square root of negative value. So this value to be rejected, and I will say my domain, since I couldn't find any value, okay, in the denominator that could make the denominator 0 or less than 0. So in here, I will say the denominator or the domain is R. Okay, so from minus infinity to infinity. So in here, starting with finding the derivative, so f prime, the denominator, so try to solve this question step by step. So the denominator, this is a quotient rule, the denominator x squared plus 1 multiplied by the derivative of the numerator, which is 1, minus, okay, the numerator, which is x, multiplied by the derivative of the denominator. The derivative of the denominator in here, let's find the derivative of the denominator over here. So the derivative of this is the derivative of what is inside the root, which is 2x over 2 times the same root, which is x squared plus 1. So 2 with 2 eliminated. Okay, so the derivative of the second one is, or the denominator is equal to x over square root of x squared plus 1. Yes. Okay, so over, so again the rule is the denominator multiplied by the derivative of the numerator minus the numerator multiplied by the derivative of the denominator over the denominator square. For the denominator square, if we squared the square root, the square will cancel the root, so I will get x squared plus 1 at the end. Okay, now let's just write it in more simplified form. So this is square root of x squared plus 1 over 1, okay, minus x multiplied by x, which is x squared, over square root of x squared plus 1 all over x squared plus 1. Now I can make the denominators the same by doing this, by multiplying this by this and this by this and the denominators together. So that will give me what? Be careful from this step. So this is going to give me equal to, so this is square root multiplied by square root. When we have square root of a dot square root of b, this is equal to square root of a dot b. Now, once you have square root of a dot square root of a, which means the expression inside is the same, this is equal to a. Okay, so in here, since we have the same expression inside the root, so this is going to be equal to the expression inside the root, x squared plus 1. Okay, then 1 multiplied by minus x squared, this is equal to minus x squared, okay, over square root of x squared plus 1 multiplied by 1, which is the same, over all over, which is x squared plus 1. Okay, now this x squared with minus x squared eliminated, and we can take this one upward over here. So at the end I have f prime equal to 1 over x squared plus 1 multiplied by square root of x squared plus 1. So this is equal to 0 from the rule, which is we have to make the derivative equal to 0. So now 1 equal to 0 from the numerator, 1 equal to 0, just to find the zeros. Okay, so that's incorrect, so we cannot find any zeros over here. Now let's make the denominator equal to 0, x squared plus 1, to find the undefined value, for example. X squared plus 1 equals 0. So x squared plus 1 equals 0. That will give me x squared equal to minus 1. And once you try to take the square root, that will be rejected because we don't have square root for negative value. And the same thing exactly will happen to the second one. So this is for the first and the second the same. Okay, so that means I have no undefined values. So no zeros, no undefined values. That means we have no critical numbers, no real critical numbers. That's it. خلاص. Since we have no critical numbers, so we cannot find any local maximum or local minimum points. Okay, that's the end of question 20. So next slide or next video, inshallah, we'll explain how to solve the question if it's included by absolute value function. See you then.